I was hanging out with Carl last week. Carl asked about this whole, moving from replicating a bit in this kind of correct by construction approach to replicating like a whole blockchain.
Mm-hmm.
And I was able to kind of walk through the correct by construction approach with pretty much identically the same philosophy as I have for the binary consensus, making the kind of relevant changes on the way and ending up with like this blockchain construction with basically only like the same two slashing conditions that I kind of always have, which is like invalidity and equivocation. I'm hoping to like walk through that at some point, but that's basically my update. Pretty much all of it.
Cool. That's awesome. We have a little bit of an update. Kent is here he's a summer intern working with RChain Cooperative. And we've got the Rolang compiler compiling the sort of hello world examples, and we also have those running now. And Kent said he might be able to give us a demo this morning. Kent, are you there?
Yep, indeed. Hello, everyone. Just a quick intro, just as Greg gave. If you don't mind me sharing my screen.
Rocket, yeah.
So here's just starting from the Rosette side. This is what the Hello World contract compiles into, and so this is the contract. Essentially what's happening here is that we're passing in two values. These are channels into a method called Hello World, and it suspends on consume, waiting for something on world 1 to be passed in. And once data comes in, simply that gets produced out on world 2. And then we have this separate printer contract that waits for data on world 2. Sorry, I forgot to paste in the namespace, but we have this simple printer contract that waits on another channel that you pass in, and this will be world 2. And let me just show you the invocation. So this is the simple printer contract where we're passing in world 2, and this is the actual channel that it's listening on. And so right now what's happening is that we're invoking the original Hello World contract and then the simple printer contract, and now the Hello World contract is just waiting for data on world 1 to get passed in, and the simple printer contract is waiting for data on world 2 to come in. And if you actually invoke it here, invoke or produce on world 1, the whole thing just goes through and then it prints the Hello World. So kind of a complicated Hello World example, but there it is. And that's the side from Rosette. Actually, if I can switch over quickly, I think I can get to the compiler side. So the compiler, I think everyone has an overview on this, but it's written in Scala, but the idea is the Rolang is compiled into what you just saw, which is the Rosette code. And we have it here. So that's the output, which is basically the same as what you saw earlier with the Hello World contract. So yeah, that's my update.
Lee, thank you. Actually, can you leave leave the contract up. Actually, we didn't see the Rolang part of the contract.
Oh,
The source of the compiler.
did the
So you
can you oh yeah, sorry, I rushed through that too. So this is the source, and then yeah, that's the output of what it's compiling into.
Yeah. So the Hello World example, it makes a contract called Hello World contract. So the initial contract in Rolang's is a declaration for a contract that's called Hello World, that's parametric in World 1 and World 2. That's what's highlighted above. And there's the for comprehension is line 2 there, and it's waiting for a message from World 1, and then we'll produce it on World 2. And then that gets compiled into 2 statements. One is a def actor for the Hello World contract entity, and the other is the Hello World operation, which then which then is interpreted as a method on the Hello World contract actor, which takes the World 1 and World 2, and then produces the. It looks like that's producing the map as opposed to just the consume.
Oh yes, this still needs some changes here actually.
Yeah.
Oh,
so we found that there's a kind of slightly narrow discipline on the reflected methods versus the delimited continuations. So we have to do in-place consumes for the rather than have the map API, and that's because with the delimited continuations, you can maintain a tree of continuation return points, whereas with the way the discipline on the Rosette reflective methods, it's a strict stack. So we have to put in, rather than call map, we have to call consume directly in place. And that's what you saw in the Rosette code on the other side. So most of this is checked in, is that right, Kent?
Yeah. Can we discuss about the pattern just after this call? That's the only thing that needs to be resolved. Yeah, cool.
Yeah, sure. So that's that. And then also on our side, let me see if I can find the document now. We are, so the relevance, of course, to Casper is that we'll, on the Rolang side, we'll be writing the a big chunk of the Casper implementation in our chain as Rolang contracts. And let's see if I can find the other. Hang on a second. I'm just looking for. There we go. Okay. We also have been working on the costing mechanism. So this may be interest to folks, given that Rolang has a fairly clean system. Express our contracting, our costing mechanism in a very nice way that just follows the semantics of the virtual machine. So I'll just do a quick screen share here, and for Vlad or anyone else here who wants links to make comments here. So essentially, what we're doing is our cost function takes a Rolang program and produces a decorated Rolang program. I don't know, hopefully everyone can see my my screen. So the example would be the contract, like the Hello World contract you just saw. So it comes in undecorated with any cost, and comes out as a version of the program that's been appropriately decorated with cost. And it's recursively specified. Now, the interesting thing about this function is that the cost is actually a vector. So we have a cost of memory, storage, and network, as well as compute cycles. So it's a 4-tuple. And the basic shape of the rules, which you'll see in this document, run like this. And it's all based upon the fact that there's essentially only one kind of transition in the virtual machine, which is an input meets an output. And then when an input meets an output, then we transition to the continuation of the input with the data, the payload from the output being supplied. So the costing function is written again in SOS style or structured operational semantics style that follows the structured operational semantics for the VM. And the idea is if you've got a channel that's a memory-based channel as opposed to network or storage, and you know that the payload is expected to be of type T, then the cost function of the forward comprehension is going to be calculated by calculating the cost of the continuation. Now remember, the cost of the continuation returns a pair, one of which is the 4-tuple here, and the other is the potentially rewritten continuation. So you go and calculate recursively the cost of the continuation from the forward comprehension. You get back a pair, and you let R be the cost annotation, and P be the potential written continuation, and then you calculate a max on the size of the type here. That's your payload times the channel access. Oh, this is the parens are wrong here. Sorry about that. That paren should be over here. So that's the max of the type of the payload times the cost of the channel access. That's what this notation represents here. And then you add that in, and then you zero out the other vectors, and you add that in here, and then you plunk that down into the pair, which contains the forward comprehension with the potentially rewritten continuation and the cost function. So that's how we calculate forward comprehension stuff, and the rest of it is very, very straightforward because it just follows this kind of pattern. The place where it starts to get interesting, with respect to compute power is, of course, when we have all the primitives. But the framework is set up, not only to be parametric in those kinds of primitives, but parametric in other kinds of primitives as well. So as people extend Rolang with additional built-in functions, then the costing algorithm needs to be extended with the cost of those primitives. So that's the basic shape of that. And in terms of the compiler pipeline that you just saw, so this can fit as a plug-in to the compiler pipeline, and this is a part of our general architecture. The idea at the end is that once we've bootstrapped, then the compiler architecture will actually use the blockchain itself. So we'll have tools which with intermediate formats that write to the blockchain, and that way tool vendors can kind of participate in the economic engine that's being created. So if you have a Rolang optimizer, then or if you have a special purpose a set of tools for cost optimization, these kinds of things, they can all be sort of plugged into a pipeline, and then people can select various tools in their tool chain as a part of rendering the contract to the final code that gets run in the VM. So that's our update. Not as much direct Casper results. Oh, actually, my mistake. There is one other quick update. So I did. Mike and I have done a kind of. We did a second round of review on the application of the what's called the int construction. So that's the construction that I've been using for the interpretation of consensus as trace. So we did another review of that, and then Mike asked a really interesting question, which basically, as I understand Mike's question, and I'm happy for Mike to jump in, is he's saying, well, found an interpretation of a compact closed category in terms of the process algebras. Can you go the other way? So because it looks like everything here is.
Sorry, can you ask the question again? And catch that.
Yeah. So Mike asked the question. Actually, Mike, why don't you just tell the story? Are you still there, Mike?
We followed this procedure for building up a compact closed category, and a category theorist would want to start from the category theory stuff and work his way to a process calculus. So I was wondering what the relationship was between the internal language of a compact closed category, which is a well-defined thing, and the process calculus language.
Right. So in other words, if you start from the basic elements that you need in order to do this consensus as trace thing, can you work your way backwards to a kind of minimal process calculus that has consensus as trace built in? And so Mike did a little bit of work coming up with a term language for that. So that's another update. If you guys want, Mike can give a little description of that.
I think it'd be good if we took a break from the category theory pi calculus stuff for now.
Okay.
Kind of do a wide and deep thing.
Sounds good.
V, do you have any updates?
Can people still hear me?
Yeah.
Yes.
Yes, okay. So I have been working on that kind of new version of the MOF paper, I guess you can call it, which describes the current version of Casper. And that includes like the minimal slashing condition stuff, it includes validator set changes, it includes economic analyses. I spent a bunch of time last week doing a griefing factor analysis for Casper. And I basically was trying to figure out like what are the right ways to set all of the different penalties so that the griefing factors can be minimized. And I came up with a few possible sets of griefing factors. So I have a fairly hard results that the griefing factor, like if you want to maintain a hard griefing factor cap in all cases, then the lowest the cap can be is 1.5. And that's assuming zero validator churn. So with validator churn, it goes up kind of linearly the more the churn is. So that's one kind of result. Although one opinion I have is that realistically, it would be better to have a system that allows slightly higher griefing factors for validators that go for collusions that are larger than 50%. In exchange for lower griefing factors for smaller coalitions. And I did this, and then from there I came up with this mechanism that has these griefing factors of 2 for majorities, and then either 1 or 0.5 for minorities, depending on what you're trying to do. That's actually pretty powerful.
Yeah, is there a place where we can figure out where you've written down how that's tunable? Because I'm curious as to how you're even parameterizing that in that way.
Yes. Hold on. It should be up in the Skype channel. Let's see if I remember what it is. It's Vitalik files hold on.
Casper notes.
Yes. Let me just confirm that the file exists. Hold on, taking out my laptop.
Casper underscore note dot HTML.
Correct, yes. Vital, can you all link to that in the channel?
Yeah.
Okay. Yeah, so in there, like in the last section, I have this big, so I define basically 5 types of penalties, and then I have a big table where I basically describe what all the 7 types of griefing are and what the griefing factors are for each one. And then I just basically do I have a Python script that just does a brute force minimization over it.
Oh, that's cool.
Yeah, that's really cool.
Yeah, so basically, if the griefing factor is only 0.5 in the specific case where you're dealing with like attacks that actually try to prevent finality, then that's really nice because it does mean that if more than 33% go offline, then like you can recover and get back to the state where like you have 2/3 of the remaining validators are online with the kind of good guys not even having that large losses, which I think is cool.
Yeah, I think that's really cool. Basically, the thing that the thing in our abstraction that kind of what makes this harder at the moment for like the way that I think about it is that I kind of have like individual strategies. I think of coalition strategies as kind of lots of individual strategies, but really like if you think of the coalition strategy as like a single strategy, then maybe some like maybe we can have a principle that where like you favor lower weight players in a like a non-attributable fault situation where like you have a low weight player versus a high weight player.
Well, no, if you, in a cases where you have a low weight player versus a high weight player, you want to favor the high weight player.
But unless they have more than 50%.
Well, no, especially if they have 50%, like you still want to punish them, but you want to punish them a bit less.
I thought that was the opposite of what you were suggesting.
No, I'm precisely suggesting that so the griefing factors for my that I have right now, right, are 0.5 if the griefer has under 50%, and go somewhere between 1.6 and 2 if the griefer has over 50%.
Oh, I see. Okay, I thought I for some reason I thought it was the other way around. And why is this good? I guess just because you have lower griefing factors when they're a small attacker.
No, because those might not be attackers.
Yeah. Exactly. So the other thing is that if the attacker has under 50%, then those are cases that are more likely to just happen normally, and so it just makes less. You just generally punish people less. And the other thing is that in a case where you do have a 51% attack, you're not going to be able to resolve the 51% attack fully in consensus anyway. So you're going to have at least some amount of extra protocol governance. And what I'm trying to do is just
we're talking about not penalizing the people who are offline less, but the people who are online less.
Correct. So in this case, if there is a 51% attack, which is censorship, then this is all about availability faults, right? So for safety faults, we still can't destroy their entire deposit.
Of course.
So for availability faults, basically what we do is we say that the censors get penalized less than the guys or the guys that might be censors get penalized less than the guys that might be online. And then if you have a more than 51% attack, then basically that'll be the good guys will make a chain split, and then on the chain split, it'll look like the minority is the one that's still online, and the majority are the ones that are censoring. And so, and the majority are the ones that are offline. And so in the chain split, the minority will lose a little bit of money and the majority will lose a lot. And then in the big chain, the majority will lose a little and the minority will lose a lot. But then, like, if it's 51% attack, then nobody wants the majority chain anyway.
I mean, I think that requires a certain level of coordination on behalf of like everyone who isn't in the censoring coalition. They kind of like require they form this kind of like, other coalition.
So I think that can happen automatically.
Like, four-choice rule. It's like it'll happen with social intervention automatically, but it won't happen, just
I see.
using our current four-choice
Right. In
rule.
order for it to happen automatically, it requires that active four-choice rule shenanigans. Yes.
Yeah.
But like in general, right?
But as a description of the griefing situation, I think I understand.
Yeah.
Basically,
well, like the idea is that there are theorems that say that it's not possible to have consensus that can beat 51% attacks without shenanigans, right?
Sorry, I didn't follow that.
There are theorems that say that it's not possible to have consensus that can break 51% attacks without, consensus that can survive 51% attacks without using shenanigans.
Do you mean like censorship, like liveness, or do you mean safety?
Both.
Yeah. Okay. Well, both is kind of, it's kind of like the kind of unfortunate answer because like it forces us to trade off between like liveness faults and safety faults, which are kind of like quite different.
Right. Mm-hmm.
No, we can
yeah. So like
a lot of safety faults.
I'm thinking about.
But we can't.
Yeah. So like generally, I think about liveness faults because liveness faults they seem to be the harder ones to get around.
Mm-hmm. Yeah, I mean, when we're talking about censorship, we're talking about liveness faults, and I think that with 51%, like censorship is definitely possible.
Mm-hmm.
Yeah, I'm still trying to digest why you like this kind of asymmetric griefing balance as opposed to say something like just maximizing robustness against like this like extra protocol attacker.
Basically because I really like the effects that if you do have a 51% attack, then like the minority chain is going to be chosen anyway, and so like I like the idea that basically once everyone switches to the minority chain, the good guys get to lose less money because making the good guys lose less money is a good thing.
Yeah, I mean, I hear that, but at that point, if people have to hard fork to the minority chain, they might as well like hard fork.
No, this is not a hard fork. This is a user activated soft fork.
Okay. Oh, my bad.
Right, because all you're doing is you're just like invalidating a chain and then you're following another one.
Yeah, sure. I mean, basically, it's like a weak subjectivity switch.
UASF.
Yeah. Okay. I mean, I personally am still like subscribed to this idea that we should set these payouts to maximize robustness against external attack, which I think will lead to like some reasonable balance of griefing bounds. But
I guess the consolation
because there is this there's a trade-off, and so like I think there will be like a reasonable balance rather than for it to go to extremes.
Yeah, I mean, like the consolation I could give is that this approach that I have only increases the griefing factor bound from 1.5 to 2.
Okay. Yeah, I'll let you know about my griefing factor bounds when I get there after maximizing the kind of like robustness of the thing in this like multi-step game interpretation.
Right.
Cool. Anyways, if no one else has an update, maybe Carl does. I'd like to go over this blockchain thing before we run out of time.
Sure. My
Carl?
hyper rapid update because I'm excited for you to go for the blockchain thing. is I'm just basically working on the implementing some basic validator logic. It's basically done, except, I mean, definitely not the best, like the smartest validator. But it is cool because it means that we can have kind of more real feeling simulations of the protocol, which should be fun. And there are a couple other things, but not fully worth it. Just like small modifications to the Casper contract and stuff. So that's about it.
Sweet. Cool. Well, yeah, I'm excited to talk about this. Basically, I'm just going to kind of give the algorithm in the kind of natural presentation, the same way that like the binary consensus is given. Natural in the sense of like, okay, natural, assuming that you already kind of know how the correct construction approach works. Basically, we're going to define like an estimator and then like the safety of that estimate. And then we can have like this notion of like, you know, consensus safety via estimate safety as like our kind of correct by construction proof that everything is design satisfied. So basically to like construct the consensus protocol, what we kind of need to do is like to say what the protocol messages are, to define the estimator in terms of that, then to define the kind of slashing conditions and the ideal adversary, which kind of influence the safety oracle. So, you know, basically, we need to do a little bit of your bureaucracy before defining the estimator, before we can define the ideal adversary. And the data structures are pretty simple. Basically, we're going to have these things called blocks. Blocks are very similar to bets, only they have they also have this list of transactions. So basically, they have like a list of transactions, and then the normal kind of like estimate, justification, sender, triple. And basically, the way that everything looks is kind of as follows: like the transactions is basically just like a transaction list. We're not really going to look in there. We just kind of note that it is accompanying everything. For like, you know, just so that we can say that we have a, you know, fully ordered list of transactions. Then we have this thing called the estimate, which is going to be the head of the longest blockchain. So out of like all of the blockchains that are in the view given in the justification, the one that is like kind of the longest, quote unquote, which we haven't actually defined yet, is going to be in the estimator. So actually, sorry, I got ahead of myself. The estimator is just a block, right? So there's like the estimate, sorry, the estimator is a function that takes views and produces blocks, but the estimate itself is just a block. So we have like transactions, some block, which we can think of as like the previous block, right? The justification, which is basically just the last block we've seen from every other validator, including, you know, the sender's own last block. And then the sender is like kind of the validator's account number. So every block has, you know, transaction list, a pointer to some other previous block, and this justification, which is like a set of latest blocks seen by the sender of this block. And basically now I need to give like the estimator, which will basically filter these blocks into like invalid blocks and valid blocks according to whether or not the block that shows up in the estimate is actually the result of the estimator. And the estimator implements the fork choice rule. It goes as follows. In a particular view, which is a set of blocks, we will like kind of start, and this is all parametric in like this kind of starting point, which is itself a block. And then from that block, you look at the different blocks that are on top of it, and you pick the one which has the most weight in. Someone's whispering and super distracting. Hey V.
Yeah, sorry. Oh, hold on.
Okay. Hey. So we have some block, and you know we have all these other blocks that like are kind of on top of it. We need to like choose one of them. And we're going to kind of do this ghost-esque style, kind of following the blockchain from the bottom up, making a fork choice at every junction. And basically the way we're going to do it is by following a majority of the weight. We're going to look at the latest blocks we have from each validator, and if the more weight is on this fork than any of the other ones, then we will go down that fork, and using this decision rule at every branch. And then the result will be the block on the at the very end, after we get to a point where we no longer have any blocks. So this kind of implements a fork choice rule using effectively precisely the Ghost protocol. It's a greedy heaviest observed subtree, where the weight is the weight of validators on that chain, according to the latest blocks that you have in your view.
And two trees can never be the same weight?
Yeah, we have tie breaking because of tie breaking on the weights.
So it's just like sorted by hash or something?
Yeah, well, really what I'm going to do is, at least the plan is just to add a random epsilon to all the validators' weights. So they each get this random number that is used for tie breaking.
Okay, cool.
Yeah, I know. So it's one of my favorite things. That there's no ties because of just a little bit of crypto shenanigans. So we basically have this fork choice rule thing, which is this estimator, and then a block is invalid if the block that it has, like the pre block, isn't the block returned by this fork choice rule on its justification. So basically if their pre block isn't the result of running the fork choice rule on the view and the justification, then they kind of are Byzantine, and that's one of the slashing conditions. The other slashing condition is for if you have two blocks from a validator, neither of which are in each other's dependency in the kind of classical sense of closure on presence in justification. So if two blocks, neither of which are before or after each other by this kind of search through the justification graph, then those are an equivocation. And then basically, we basically have everything we need to start to solve the elementary kind of example. But basically, we kind of assume that we have a view which is made of valid blocks from validators who don't equivocate, and then our job is essentially to implement an ideal adversary in order to kind of implement this notion of estimate safety. Sorry, I haven't actually defined estimate safety. Estimate safety basically is going to be a proposition that says, in all possible future views, in some context, this block will be in the longest chain. So you pick a block, and then you ask will it be in the longest chain in all future contexts? And then the answer, if the answer is yes, then there is estimate safety for that block, for the estimate, and estimates are of the form this block will be in the longest chain. And so basically we need to kind of use the definition of estimator and models of all the validators in order to try to search the possible future states of the protocol for one in which the kind of victim, the one who's running the ideal adversary simulation, has their fork choice changed in a way that leads to that block no longer being in their longest chain choice. And it's a relatively simple thing because it turns out to be basically, an n-ary decision at every height, at most, where technically it's always going to be n-ary, but n might be 0 or 1, depending on kind of what happens. And also you have to note that the model validators can make blocks kind of out of nowhere in this ideal adversary thing. So just because there's no current blocks competing with a block doesn't mean that the adversary can't create some. So basically, we need to really have the situation.
Vlad, this sounds like the algorithm that you were describing when you were last out here in Seattle.
It's precisely the binary. Yeah. So it's kind of that, only now it's minimal and complete. Well, no, sorry, that one, the one that I was giving used ranked voting. So it was more leader free. It doesn't require the production of a blockchain at all. It just uses an arbitrary DAG. and kind of the estimator was the
Okay.
result of a ranked voting protocol of the justification.
Yeah.
Whereas in this case, the estimator is just a choice of the longest chain.
Yeah. Understood.
So it's
Understood.
kind of it's much more efficient. It's much easier to calculate the ideal adversary because of the nature of ranked voting being a kind of tricky thing due to the fact that you're dealing with ordinal numbers.
Now, one other question is tie breaking transitive? So if the tie between A and
no, it's like one of these I mean,
suppose that the way
it's not necessarily, but we get it globally using cryptography. So it's basically it's not. You can kind of see that it's not if you try to say
suppose that B is chosen in the tiebreaker between A and B, and C is chosen in the tie between B and C. Is C chosen between A and C?
So that depends on like how you set up the tie breaking actually. But tie breaking.
So you're saying there's a way to set it up so that. Yeah, I'm having a hard time constructing the one in which C doesn't win.
Imagine you just compare the hashes of their names, and whichever one is lower wins. So then, you don't do it on the kind of weights, but you can institute tie breaking rather than on the weights, on just like the result of the estimator.
Won't that
so
be?
Like the estimator
Won't that be transitive?
Not necessarily. It could even be. No, it just needs to be deterministic.
Yeah, I understand, but I have a feeling that every deterministic algorithm will be transitive, in which case you'll have a king validator. And
I'm pretty sure that's untrue. We kind of already have like a king validator, even if it was true, because like the whole fact that validators have different weights. And we're just like naturally have one maximal size validator. But tie breaking is going to just make sure that there's never a tie for who's the biggest.
But for me, the bigger question is: do you know who this king validator is in advance? When do you know that information?
Yeah.
Well, I mean, there's like immediately all the weights. And then the question for how tie breaking works. Okay, there's two main ways to it. Like one of them is to add a random epsilon to all the weights, and the other is to say whenever there's a tie, it's basically to do it at the estimator level, where basically whenever there's a tie in the weights, you have a rule for how to break it, so that if anyone who shares your view will break it in the same way. And it's really. You can compare hashes of names, in which case you're not going to get this transitivity. If you assign tie breaking to the weights, then you will. But anyways, that's hopefully not the most interesting thing about this blockchain kind of presentation.
To be frank, Vlad, it's the most interesting because it's the only attack vector I saw.
Oh well, I'll take that as like a compliment. But there's no real way to have a tie, because for any given set of validators, for any given set of latest blocks, everyone has like a unique block which they claim is the longest chain. And then on every fork, there's going to be like some of them on one chain and some of them on another, or really some number of them on any n. And if the tie-breaking property just asserts that any subsets are not equal, then there's definitely going to be one of them that, but actually we need a slightly more sophisticated tie-breaking property that says that there's always going to be some subset which is bigger than all of the other ones, not just that they're not equal. which I think it is the case if they have scalars. But if we're just talking about like this relation of like who's going to win, you kind of would need it to be global. So I guess the hash comparison thing is a little bit of a harder trick to pull off in the n-ary case and the binary case. But with the random epsilon weights, there's always going to be one that has the biggest weight, just because we basically have to stick the weights which have the tie-breaking property into like n mutually exclusive pots for every forking point in the blockchain. And so, like, as long as we have this tie-breaking property, then we're going to uniquely be able to pick an output of this estimator.
So I think it implies a total order.
The estimator is 0.
I think tie breaking implies a total order.
I think in this case, yeah, I think it does. It's for the n-ary. For the n-ary thing, the way that I'm using it right now, but actually, like, I'm actually sure that there's a way to do it without an order. It's just a matter of crypto shenanigans. It's gonna be possible. Because we just need to sample. It's just like a fiat Shabir thing where you have a commitment and you sample out of the set using the value of that commitment.
But it's within a given view, though, right? So within the same view.
That's exactly right.
Okay.
Yeah. That's why I'm sure it can happen, is because like that's the only constraint is that two validators with the same view make the same estimate. So the cool thing about this is that the ideal adversary calculation is pretty much exactly the same as the binary one, only basically it's n-ary and we do it in an iterative kind of manner. And from like some like initial block that the whole safety calculation is parametric in to the block that you're asking about the safety of. And that initial block is basically the last finalized block that you know about. So it might be Genesis, or it might be like some kind of checkpoint, or it might be some subjective client decision, or it might be the like end of an epoch if we have an in protocol threshold. But there's like some block that you kind of start at, and then you do a bunch of n-ary adversaries until you get to the block in question, and then like that kind of answers the safety question. It's cool also just because the slashing conditions are super minimal. There's just like equivocation and invalid blocks. Just like I think whenever you run this construction through, it's going to give like that set of slashing conditions. And the adversary, kind of as usual, it goes ahead and just like does its best to move validators off of the fork that your block is on to another fork. By basically like doing the same kind of shenanigans as like the normal binary one would do, basically showing validators blocks from forks that are different than the one that that your block is on. Basically doing everything possible to promote other forks than the one that the victim is on. And basically what it'll do is it'll pick the one that the most weight is on that isn't the fork that you're on, and kind of try to make that one win. And then there's like the normal kind of caveats of efficiency and finding bounds on the adversary. Another cool thing is that you can make blocks, with like empty transaction lists, just in order to quickly stake where you, which fork you're on, which can lead to like much faster finalization than if everyone were to say make a blockchain in a row. But still, people will like agree on the fork choice rule, and so like without changing the protocol at all, you can make blocks into these like validations or like extra finality messages without any change to the protocol. which I think is like also quite cool. Basically, because they serve as a commitment to what's the longest chains that they've seen so far, which kind of always will restrict the ideal adversary, because it forces them to equivocate to produce certain sets of bets, which may not actually end up having any effect, because if you showed me those bets, I might recognize them as equivocations.
So are you at a point where you can collapse the justification structure directly onto the blockchain?
Sorry, what do you mean by collapse?
Well, I mean, one of the reasons I wanted to separate the message structure from the blockchain structure, because initially when we started talking about this in 2015 or so, or 2014, I can't remember. The messaging and the blockchain were kind of identified, and that leads to all kinds of weird loops in your reasoning.
Yeah,
makes it really hard to read.
This definitely identifies them again in very
right,
almost identical fashion.
Yeah, right. So I mean, the trick is to separate them, prove nice properties, and then show, well, if we identify them, then we lose nothing, and so then you can get more efficient. You don't, the blockchain can be the messaging structure all at once.
Yeah, I'm just doing it because it's like convenience for proofs. Like I think is like the main thing. Like I could have two message types, and like the first time I kind of worked on it, I did. But when I did it like last week, I only had one message type, and it was just like much easier to like see why everything worked.
Yeah.
But I hear your concern. But I'm excited for like this blockchain inception process where like the transactions become like, the justifications enter into the transactions and like, feed the incentive mechanism.
So you critically depend upon the property that the transaction list is a total order. Is that correct? What happens if the becomes a partial order?
I don't critically depend on it, but like all I'm doing here is I'm creating a single chain of blocks, because like that is what the estimator does is it picks out a chain of blocks essentially. I mean, and the data structures, they like design the same chain of blocks. Like this I just decided like, okay, I'm going to make a consensus protocol that replicates a blockchain. Like you are going to need to make you're going to need to wait a second, Greg. Let me finish. You're going to need to say I need to replicate the row calc VM, and then figure out how this process is going to work for you for that, right? Like there's like the data structures like have to be chosen from the start in order to replicate the type of data structure that you want.
No, completely independent of the row calculus VM. The issue is that in order to scale, you've got to have partial orders on your transactions. I mean, you just can't.
we know, Greg, we have like sharding for that, and like.
Yeah, but Greg, I think that's
designed to be sharding. This is even designed to be scaling. This is like just showing that the same process that I'd use to derive the binary consensus in a way that is like like kind of correct by construction, like also works for other data structures.
Right. So I'm probing the limits of I'm probing the limits of the proof technique. So the question is, does the proof technique, as a proof technique, is it robust against the transaction list being partially ordered as opposed to totally ordered?
The proof technique has nothing to do with the underlying data structure that's being replicated, actually.
That's what I thought. So in which case you can the transaction list can be partially ordered.
Well, no, in which that would be another consensus protocol. You can make another consensus protocol that replicates a partial order, and that would require like a different estimator and a different definition of safety.
But don't you not need a partial? Can't you sidestep this issue with namespaces? Maybe that's a little crude, but doesn't that work?
Well, that's I mean,
Yeah,
that,
so,
so
there's
the
totally
question,
there's
the
totally
question, how does namespacing interact with Vlad's proof technique? Right, and so far, what I heard in the proof is that it doesn't change. The proof technique itself doesn't change if I change the payload, and that's what I'm trying to make sure I've understood correctly.
Yeah, that absolutely seems
So
to be
right
the
now, the
case. I mean,
payload is an ordered list. So if I change the payload to be, like ordered list, but a partially ordered list, does the proof technique change? And as I understand Vlad's proof, it doesn't change. In which case,
it doesn't change. Yeah.
there's a nice, okay, yeah, that's kind of
Yeah,
what I
and basically what
was driving at. Well, that's
and basically what you need to do for any particular payload is like define an estimator that takes a view, which is a set of protocol messages, and produces a value in this payload, in this possible payload, right? The reason why I use blocks in the blockchain is because every block uniquely identifies the blockchain kind of jetting out of it in like the kind of direction towards the Genesis block.
yeah.
And for the partial order, you need to like have some kind of set of like terminal nodes that like characterize everything, and so your estimator is going to have to like output that, say, and then from there, you need to think of the definition of an estimate of estimate safety, which is maybe going to be a little hairy. Maybe it'll be like this node will always be unordered with respect to that one, or this one is before that one, or this one is after that one. I'm not sure. And then you need to define this kind of ideal adversary that basically is specifically designed to try to make your estimate, which is like some claim about these partial orders that we're going to agree on in the future.
Right, and Rick, the namespacing is where the partial ordering gets resolved in the estimator. So the namespacing provides the additional ordering mechanism that you need in the estimator to figure out whether two transactions from two different partial orders need to be ordered or they can remain unordered.
Okay, yeah, that makes sense.
Yeah.
Yeah.
Cool.
So I think that like we should just kind of like take these one at a time and kind of see us kind of get better over time at defining these adversaries and kind of implementing them, and also finding balance on them. Finding balance is like sometimes incredibly boring and easy, but when you want to find like ambitious balance that are like closer to the adversary, it becomes much harder. Like if you only look at like symmetric graphs, it can be that have like a certain compactness to them. It's very easy to come up with like a proof and say, okay, look, this is all we need. Just like produce this protocol and like we'll all be safe. But somehow I don't feel like super happy about that, because then we end up getting like somehow very similar stuff to normal consensus protocols, rather than having this like looser feel of being able to get safety and more possible network passing kind of orders.
Yeah, this is really cool.
Yeah, I'm pretty excited about it.
Yeah. I have a 9 o'clock that I have to get ready for, so I'm gonna bounce off. But this is again another quality stand-up.
Yeah, it's been fun. And if anyone wants to talk about the blockchain, I'm happy to stick around for a few minutes.
I can stick around for a bit, so I'll be around.
Cool. Carl,
What
Ciao,
about
guys.
the blockchain do you want to talk about?
if you have any questions about this like blockchain, correct by construction, blockchain kind of consensus protocol with like with like finality and everything, just like in the blockchain with blocks only.
No.
basically, the only kind of the only interesting thing as far as I'm concerned with like in general with a lot of these is like, okay, can we compute the adversary? Can we find nice bounds on the adversary? And kind of in that context, like what is the estimator? And the ranked voting estimators are kind of more difficult to come up with the adversary, which is why like I've been kind of happier with this blockchain one. I'm like pretty confident that there are super simple adversaries that we could like, template out and like have like really simple kind of type checking for, and not even have to actually do any kind of brute force calculation.
Mm-hmm.
But doing the brute force calculation is so much more satisfying because like you just kind of like end up feeling like you really like have a much stronger indication of whether you're safe or not. In this like world of like many possible DAGs of blocks, or in this case, it's like a tree with lots of forks.
Mm-hmm.
The cool thing that I like about it also is that it kind of combines this blockchain as fork choice rule thing with a strong notion of consensus from the point of view of like, all future protocol executions from this particular state of the blockchain protocol, which I think is quite cool because, usually you have like either a blockchain or consensus and not really both unless you kind of hack it and like not really have any kind of notion of fork choice.
All right. I mean, that's all sounds good to me. I guess how far away are you from? I mean, it sounds like that stuff's mostly implemented then, right? I mean, it sounds like if the binary consensus is already implemented and this is so close, what's missing?
Yeah, I mean, I think it's just like, a matter of like kind of doing a few sprints.
Mm-hmm. And the breathing factor analysis.
Oh yeah, well the economic stuff is like and validating rotation stuff is like is like also needs to be like done also for this thing.
Yeah, once you add incentives, yeah, that's going to be a whole other fun thing.
Once I add in what? Sorry.
Incentives, because like with
yeah.
incentives are fundamentally part of the state, so they can't be subjective. So you have to like do weird stuff.
Yeah, no, I'm totally excited. I think I have a pretty clear plan. Basically, I'm gonna like implement I'm gonna implement a validator inside the consensus, which is gonna like judge how much it likes what it's seeing and pay people out accordingly. That's effectively the way I'm thinking about it.
Mm-hmm.
But it's gonna be cool. The thing I like about having the simple underlying protocol though is that fewer protocol messages means that it may be easier to enumerate all of the possible faults and like the whole strategy space. Yeah, I'm pretty stoked. The more from the ground up everything is like completely correct, and like easily demonstrably so, the like happier I am. I feel like we definitely have a lot nicer little like portfolio of proofs and results than we did say a year ago.
Yeah, I mean, it would be nice if we could. I mean, I think we do like. I mean, are we gonna start like just explaining all this stuff on Twitter, because that seems to be actually happening, which is amazing and weird.
It's just the easiest way for me to communicate.
Yeah, yeah. I mean, you should start like telling stories, like epic tomes on Twitter, because apparently this is all we can do, as opposed to blog posts or something more. Because
you don't think so? Yeah. So do you think I get many less hits on the blog posts? Is that what you're saying?
Well, people aren't reading them, and then they go to Twitter to argue, and they don't read anything first. Which is like, I don't mind arguing, but it's like ridiculous to read an argument from like pretty smart people who are just like basically like, I haven't read anything. And you're like, well, why are you here arguing then?
Yeah, I think we need to do it. Like, I think we need to communicate all of this stuff on all fronts. I don't think that like any one means is going to be sufficient.
The other thing with Twitter trolls, though, the thing with Twitter trolls, though, is that like there's two types of people who don't believe in anthropogenic global warming. The first type is like well-meaning 12-year-olds who are just like think, oh, it could just be sunspots, and they're just like totally well-meaning. They just like haven't read enough yet. And then the second kind of people are like basically the kinds that are of like already think they've gotten all their education from their own weird media sources, and like quite possibly no amount of persuading is going to have an effort. So
unless it's in the form of a counter conspiracy theory.
Oh yeah, that would be great. Yeah, we could think about counter conspiracy theories.
Yeah, I find that interesting to navigate, and I'm also, I think that counter conspiracy theory narrative and the trolling narrative is really interesting because the way I deal with trolls and engage with trolls, we all have our own styles, I guess, but I don't, when someone from the Bitcoin space who actually, is like pretty knowledgeable and, maybe even has a PhD in something. And they're like, well, and they're basically like, I haven't read anything about Casper. I don't really understand it, but based on some other tweet, I'm going to go off and say some crazy thing. And you're like, okay, well, I don't know. I feel like the alternative conspiracy theory there is that there's a magic blog post that the magician Vitalik wrote that addressed this like a year and a half ago. Like, I'm not sure what the alternative narrative can really be in that case, but I am certainly open to suggestions.
Well, normally what I do is I try to like take it on a case by case basis and like feel them out and kind of, provide like the tailored response. But it is like something that is like, not necessarily time efficient. Maybe we need to do like the Bitcoiners and form secretive chat channels with trolls that we have to train and hire to spread the word about proof of stake. But I think that's a little ridiculous. I think we should just like kind of, I don't know.
Well,
just do public education, have it naturally happen rather than kind of do it in a more shady way.
Well, there's pros and cons. I'm open to. I guess I'm sort of taking this on just because I feel like I don't really want to take it on, but I just feel like a lot of times when I'm talking to people, papers haven't come out of this process in a way that people can consume them as papers, which I think is fine because but it's also, the amount of work that's been done is certainly like worthy of a paper or two or three. Like 3 15 pagers I think would totally be reasonable at this point. I know that I don't expect that to come out of this group, and I don't think it should come out of this group. On the other hand, it is what other people are expecting. So I feel like we should sort of like meet them halfway with something.
Yeah, I think it'll come out of like, us cooperating with like academics who want to get published. That's probably the best combo because like there's people who like, are happy to spend inordinate amounts of time thinking of playing this like kind of like peer review game theory in their head.
That's an interesting point.
To the kind of like the kind of like the succinct communication that we prefer to do in blog posts.
Yeah, that's a good point. So Vlad, we should talk about this again offline sometime.
Sure. Yeah, I'd be happy to. Yeah, I mean, in terms of different formats, I mean, I think we just need to produce as much a wide educational format as, say, people have done about proof of work. You know,
Yeah, but that
just to,
happened
let
over
that sit
so
in.
many years, though. I mean, that's the thing, right? I mean, it took
I know,
years and years for
and
that to happen.
And it's going to take years for us too, very likely. But maybe we can speed it up if we're good. I don't know.
Well, but I feel like we're going to transition to proof of stake before that happens, right? I mean, that's the issue.
Yeah, that's true. But education is important because we have to train engineers who understand how to build these systems so that we can keep on keeping on, right? On this current crypto economics thing.
Yeah, so I think
from amateur hour to professional win.
Yeah, and so I think the risk that I'm seeing, which is frankly, I think it's a really small risk because I mean, sometimes it's hard to tell how big of a risk I think something is. I think it's a really small risk, but what's going to happen is we're going to switch to Casper, and we're definitely going to be running a hybrid chain before anyone else really understands what the F is going on. And they're going to say all sorts of crazy FUD, which, ultimately is fine with me. But as we go through that process, what's going to happen to, I don't think the Ethereum proponents are going to be too worried, like the core people. But sort of the outliers, and I guess it's almost like all Twitter trolls, really. So I guess you can kind of just ignore it, right? I mean, it's just going to be all Twitter trolls saying, "Oh, this isn't going to work because of long-range attacks."
Yeah, to some extent we can ignore it, but also we need to make sure that responses to all of their criticisms are available.
Yeah, I think that's a good check and balance sort of thing. I mean, like Munib's thing recently about the forks, he's a smart guy, but he seemed to be.
I mean, he really is he's a proof of work maximalist. If I've ever kind of judged one just by the messages they say about proof of stake. I mean, he gets hung up on every single trade-off and design decision in proof of stake land.
Yeah, he doesn't seem to accept that it's a different trust model, and I feel like I don't know if you have to write that on a page 100 times or what you have to do to get people to understand that it's a different trust model, and in some cases a better trust model, and in some cases maybe a worse trust model, but it's a different trust model.
Yeah, it's hard for people to understand how to compare protocols across trust models.
Yeah. All right. Well, I'm gonna drop off. So, but
Okay.
nice
Good night for you.
Good night.
See ya. Good night.
Night.
Bye.
Nice chatting. Bye. Carl.
Yo. Twitter trolls. That's why I just don't tweet.
They're not so bad. You learn to love them.
Thankfully, this is recorded, so I can quote that.
Yeah, I don't mind. So did you like my presentation on the blockchain, correct by construction blockchain thing?
Yeah. I think it would be. Consensus? I think it would be good if at some point you I mean, we can just go over just a picture of it. I think a diagram would be super helpful.
Yeah, totally. I was thinking about
Uh,
how unfortunate it is that my Zoom doesn't work on my Ubuntu, so I can screen share.
Oh yeah.
I guess I could go on Windows.
Or not use Zoom.
Yeah, I think picture. Oh yeah, but what are you gonna use? Google Hangouts. Google Hangouts.
I mean, I don't use Ubuntu in my desktop life, so I mean, whatever works on Ubuntu, I don't know.
Yeah, there you go. Yeah. Anyways, does anyone have anything else to talk about? The education stuff is kind of interesting. I'm thinking about writing a paper with Georgios about kind of the definition of cryptoeconomics.
That would be awesome.
Yes, please.
And it would also be interesting to relate that to, I mean, obviously to his field, mechanism design.
Yeah, of course. I mean, all of it, like, I mean, a lot of it is basically like straight up mechanism design questions with like a slight application to like, you know, just like kind of with the application to like distributed systems and like protocol guarantees. Yeah,
I mean, I know this crypto economics term is really stuck. I'm not a huge fan of it, but yeah, I mean, I'd rather just talk.
I'm a huge fan. Why are you not a big fan?
Yeah, I know you're a huge fan. Well, because of what the prefix crypto usually means, and
oh yeah, that's interesting because to me that's it's super appropriate. So, but maybe we have different definitions, right?
Well, no, I mean, I see why you would say that, but I feel like it's kind of the opposite, right? What we're doing is we're creating like a maze with glass walls in it, right? We're not. It's not hidden. The economics are not obscured in any way.
No, it's not hidden, and it's not about hiding at all. It's just about using incentives to provide information security guarantees. Like not all information security guarantees are confidentiality. Right?
No, I meant in the crypto sense, like cryptozoology, right? Is the looking for animals that are hidden.
Sure. Yeah. I mean, to me, crypto just means information, like the like applied science of getting information security guarantees.
Right. It literally translates into like the study of secrets.
No, I mean that's like cryptography is like applied science of like information security guarantees, and it's like a little bit more broad than just confidentiality, right? Things like authenticity and signature.
Sure. But again, so yeah, but if you just go to a thesaurus or whatever, a dictionary, and look up the crypto prefix, that's kind of what bugs me about it. But then also the idea that I guess it is economic in a sense, but a lot of times people make it, when they talk about economic incentives, they're talking about the financial side of economics, or they're making weird assumptions about rational actors that we actually don't make, right? I mean, so it's not. So I think a lot of people, when they see that economic term in the blockchain space, they bring in their rational actor model that we're actually kind of like systematically dismantling, which to me is.
I mean, kind of. I mean, but like, only partially. Like, we still rely on like game theoretic models, right? But we just have to have like the players be implementable.
Well, but also, I mean, in the sense of griefing attacks and ideal adversaries, right? I mean, by looking at the griefing attack and looking at, what happens, how does this fail even when our rationality assumptions are wrong? I mean, I think that's actually a huge difference.
Yeah, but I think that's something that like any good mechanism design people will look at for the mechanism design problems. Like the thing that to me is like foundational about crypto economics is the idea of like using incentives to provide like kind of forward-facing information guarantees. Basically, because like incentives are forward-facing, but crypto proofs are always inherently backward-facing.
You should write a paper on it.
I know. But basically, I agree. Kind of like I think, but I don't know. So there's like this whole question of like how do you do good mechanism design, which is super relevant to us, but also more relevant to much more broadly to any information security stuff. The information security stuff is kind of more on stuff like say consensus protocols, incentivized file sharing, like certain kind of like relatively like low to like low level utilities that are kind of where basically we take like some protocol and we like convert it into one that is like able to work on an open internet, like incentivized. And like that's the kind of process that I think I'm focused on when I think about like crypto economics. I'm not so much focused on just like say like the DAO, for example.
Right. The mechanics.
Like the DAO to me is like is like a crazy experiment that like this doesn't actually have to do with like cryptoeconomic research, even though it's like fascinating.
Yeah, I
And
shouldn't
like
use the word
completely
mechanics twice
relevant to
there.
my interest.
Yeah, that's applied. I mean, that's just software engineering in the constraint of a crypto economic framework. That's just normal software engineering.
Yeah, and it's also like a normal economic mechanism, as opposed to like kind of like crypto economics.
Well, yeah, that's sort of why the term is. I mean, I understand your definition. It's fine. But I don't. I mean, from a style perspective, I don't think that the word is evocative of your definition, which is purely an opinion thing.
Yeah, I mean, it might change. Maybe over time, like you'll get conditioned to people using it in this precise way.
Yeah, exactly.
But well, one can dream, right? Who knows?
Yeah, so it's interesting too that you mentioned the DAO in that context, right? Because I think that in some regards, well, I mean, it's 2020 hindsight, or maybe this is like a tautological statement, but the biggest problem, one of the bigger problems in this space, is people are doing the engineering without having done the science first, right?
Mm-hmm.
And it's really, I feel like if I could communicate to guys who want to raise $100 million and have run a startup before and exited, that like the difference between what they did in the past and what they're doing now is what they did in the past was based on 50-year-old science from the 60s whenever they did their thing, and now we're talking about doing something based on science from the 90s, and that's actually a really big difference because it's much more recent. That'd be awesome to explain to people, but I don't see that happening.
Yeah, I mean, there definitely was an extent to which the DAO was like, an attempt to raise money, but and also like it is interesting that like the kind of downfall of DAO had to do with this like the fact that like it was hard to write smart contracts in a safe way, put it generously to like everyone.
Yeah. Yeah, it was like it came down to a basic engineering fail that wouldn't have been possible in a lot of other environments. I mean, I still think about how many people audited that code and said it was good, and how those people are all still like in the scene.
Yeah, that's true. Yeah.
Like normally, like when you normally have a functioning auditor role, when the auditor screws up, like that's it. They're out of. They get one shot to screw up basically. And the auditors in the blockchain space, in my opinion, have failed multiple audits multiple times, and they're fine. I'm not talking about Deja Vu Security, although obviously I have issues with some of their stuff. But I don't, because I understand the security space and I understand the client relationship space. What they provided was very clear, and if you read it, which I did, you realized it didn't have anything to do with anything that you would care about with regards to are these smart contracts secure, or safe, really more precisely.
But also there's like a huge under provision of like those services. Like it's not easy to find really qualified auditors who will like really take the time.
Well, we've put so much money into this. So much money has been injected into the space. Auditing is always. I mean, it's not a low margin business, but it's not a sexy business. That's for sure. And why would you need to audit something if someone's going to give you $16 million with no audit anyway?
I hear you. Yeah, I mean, at some point, if you just have to spend like $100,000 or $50,000 or $40,000, $20,000 on an audit, or like less, you'd think that like it's worth it, given like the reputational risk and the liability that you have associated with all that money.
Yeah, but that's sort of the irony, is that there really is no reputational risk, right? I mean, that's the real issue, is there is no reputational risk.
Well, I mean, there will be if people lose money, right?
the way I'm looking at it now, it looks like, and it makes sense, right? Tokens are super liquid. They're super liquid. People are willing to give up, VCs and stuff are willing to give up their governance role, which wasn't super helpful anyway, in exchange for super liquidity. And so because it's super liquid, they'll happily give you this nominal $12 million because they know that they're just going to pass the bag, right? They don't have any risk of actually really losing that money.
Mm-hmm.
So it's weird. It's funny because this actually does relate to making Casper, right? I mean, like why, the foundation is flush now, luckily, but there were times in this process where we were definitely short cash or questioning if the resources would be there.
Yeah, totally. And like that could happen again,
Yeah.
But we are a lot closer to being able to like, design these protocols in a way that is like super compelling, which I'm really excited about. I'm really excited about being able to satisfy this incredibly strong equilibrium result in like any game where I have a certain like ability to check message validity and equivocation, and like some optimal solution, which is like the protocol, which like maximizes the production of the protocol guarantees, and I can just like we're getting like closer and closer to like having like an automated process for taking some protocol and making it from like a vanilla optimal solution to some vanilla problem into like this kind of authenticated, Byzantine fault tolerant, incentivized open network protocol.
Yeah.
So even if all the money dries up, like we're definitely a much better place than we were, say, like 4 years ago or 3 years ago.
Yeah, absolutely. And I think, I just feel like so much work has been done that hasn't been communicated or is kind of, it's not even like sitting in the ivory tower. We're just sort of like, I don't know. I mean, all this stuff is readily available. All these recordings are readily available. All the Slack channel or all the Skype channels and Gitter channels are open. It's actually really easy to find this stuff, and yet we still find that people don't go look for it. It's fascinating.
Yeah, well, I mean, we don't do an amazing job of like promoting it and organizing it in a way that people can find it accessible if they're not already in these channels.
Yeah,
I think you have to really like want the information to go sift through, this kind of format. And so we just need to lower the bar for how much you have to want it to make it so that someone who only like kind of wants the information has a way to or can receive it.
So I have a bunch of web devs available to work on this. They did the new. We did some new work. It's being recorded. I won't say who it is, but we've done some work for people we both know, Vlad. So there's definitely we should, and I have Casper today, the website. So we should just finish that.
But we don't have cryptoeconomics.eth. So if you're watching and you bought it from me, like, contact me, please.
Donate that.
Donate that. It's for the greater good. Come on, like you're gonna make so much money on the ICOs.
How much did they buy that for?
It was like $6,000. I put I put a reasonable bid in, but I didn't think it was going to go for $6,000, especially because they hide the name. So it was like, I was like, oh, I opened the bid anyway. I'm so salty.
Yeah, no, I think ENS has come a long way since the last time I really looked into it. But
there's like 2 million ETH in there.
Yeah, well, I just didn't understand how they were going to stop squatting with the system that they had. It didn't seem like it was going to stop squatting.
I mean, I knew full well when it launched that there was going to be plenty of squatting.
Yeah. So, yeah. I mean, if you're going to, Yeah, so I don't know. I have mixed feelings about the mechanism because if I recall correctly, the purpose was to stop squatting, right?
Well, yeah, but basically what it did is it like disproportionately favored people with low capital cost to squat, because like if you're like leveraged long ETH already, like you have like almost no capital cost to like locking your ETH up in these contracts, and so like the cost for you squatting is like relatively low, so it kind of has like favored, I think, whales over like people who are budget constrained and who can't. And also a more interesting one is like if you're a squatter, you're not planning on keeping that deposit in there for long. Whereas if you're not a squatter, you're planning on keeping a deposit for longer. And so like the expected kind of cost of capital is much higher if you're not planning a squat than if you are.
Yeah.
So it ended up being, I think, relatively bad at stopping squatting.
Yeah, I think it's difficult to. I mean, squatting is such. Without identities, it's really hard to stop squatters. Sounds obvious, but
Well, I mean, there's other ways to stop squatters than identities. I mean,
Well, the issue is just how do they're going to Sybil. What do you do against the Sybil?
well, I mean, so as far as I'm concerned, you have just like a dispute resolution process that can be like triggered, and there's oracles that like are kind of adjudicators, or what do you call these people?
Yeah, adjudicators. Yeah,
Yeah,
arbiters.
arbiters. Yeah, that's what I was looking for. Yeah, and I think that, like then you just have like more of these systems with appeals and more arbiters looking, and like the other guy like pays your bill if you go too high, like that kind of stuff. Just kind of mimicking existing kind of court systems.
Yeah, I mean, I think that's a good idea. I mean, I think it's funny because I was talking to some people at ITF stuff. Yeah, I mean, definitely that's. Yeah, I mean, ultimately that is the answer. The answer, what you said is sort of the answer I wasn't expecting. Well, I would expect it from you, but I wouldn't expect it from the Ethereum community at large, which is, yeah, you just replicate normal dispute resolution. Yeah, agreed with that.
Yeah,
All right.
so that's kind of my ideal world for how to deal with it. And then you don't need identities. You just have this kind of like a reputation system on a bunch of these arbiters.
Yeah. Yep. Sounds good. All right. I have to go, but this has been awesome. I'm glad.
Cheers. Thanks for your input.
Yeah. I do what I can. I'll talk to you guys later.
All right, see ya. I gotta go as well.
Peace, Rick. Yeah, see you,
Later,
Carl.
everybody.
Have fun.
See ya. Bye.
Bye-bye.